Okay, so we're going to start looking at trig identities today. All the identities we're going to be working with, I've cut and pasted into the slide, so we'll be using reciprocal identities, quotient identities, and Pythagorean identities. So on your formula sheet, that would kind of be the second, third, fourth, fifth, sixth, seventh row on the right-hand column. Again, if you've lost your formula sheet or you don't know where one is, if you just Google Math 30-1 formula sheet, it'll pop up right away on any type of internet browser. Or also, if you have that red workbook, remember that formula sheet is the very last page in that workbook, so you can use that too. Okay, so we're going to start by verifying. Today's lesson, we're going to be proving identities. We're also going to be verifying. So what verify means is you're actually going to substitute a value in. When you try to prove an equation, you are proving for all values. I'm actually going to skip the one on the left. Okay, you can look on it on Moodle on the complete set of notes, and we're going to do the one on the right here. So it tells us to verify for pi over 6. So that means wherever I see an angle, I'm going to replace that angle with pi over 6. So in this case, the x represents the angle, so I'm going to replace the x with pi over 6. Okay, and then I'll do the same on the right. So I'll replace that x with pi over 6. Okay, so now kind of on the top here, tan pi over 6. Let's quickly figure out what that is. I know tan is sine over cos, right? So I'm going to go to my unit circle and look at pi over 6. So I'm going to pull up my unit circle here. So at pi over 6, remember your ordered pairs are already always written as cosine. So the value of sine is 1/2. The value of cosine is root 3 over 2. So the value of sine is 1/2. The value of cosine is root 3 over 2. So we're going to go 1/2 divided by root 3 over 2. Okay, so now we're going to take the reciprocal of that second rational and multiply. Oh, I forgot to take the reciprocal. Let's try that again. Okay, so 1 over root 3 I'm left with because the 2's cancel out. And of course, when we have a square, you can apply it to both the numerator and the denominator. 1 squared is just 1. Root 3 squared, it just gets rid of that root, so I'm left with 1 over 3 plus 1. 1 over 3 plus 1, and if you're not sure, you can always type this on your calculator. It is equal to 4 over 3. So we know the left side equals 4 over 3. Let's do the right side. So remember, secant is the reciprocal of cosine. So let's go back to our unit circle and figure out what is cosine at pi over 6. So at pi over 6, cosine is root 3 over 2. So if cosine is root 3 over 2, that means secant has to be 2 over root 3. Okay, so again, I apply that squared to both the numerator and the denominator, which leaves me with 4 over 3. Excellent, so the left side and the right side are the same. So at the very end, I'm just going to write the left side equals the right side. Okay, so that's how verifying works. At the very end, you should end up with the same answer on both sides of the equation if you did it right. All right, we're definitely not going to worry about basic identities. Those actually don't even show up on the diploma. I haven't seen one on like 4 or 5 now. So we definitely won't do it in the slideshow here. So let's actually look at writing these expressions as a single trig ratio. So we're going to be using some identities. Okay, so one strategy I always use is when I see a fraction added to something that's not a fraction, generally I want to join that together as one fraction. So I'm going to need a common denominator. In this case, that common denominator will be cos squared x. So I'll need to times that 1 by cos squared x over cos squared x in order to have that common denominator. So obviously my common denominator is cos squared x, so I'm just adding those numerators. That doesn't look like a plus sign, but it is. So I have sine squared x plus cos squared x all over cos squared x. So let's go to our formula sheet and see if we see that anywhere. Do you see sine squared x plus cos squared x? It's the 1, 2, 3, 4, 5th row down. Sine squared theta plus cos squared theta equals 1. So that means we can replace this numerator with 1 because we know it equals 1 because of our formula. Okay, so we end up with 1 over cos squared x. Oh dear, my PowerPoint does not seem to be loading again. So 1 over cos squared x, you can kind of look at your formula sheet again. 1 over cos x is secant, right? So that means 1 over cos squared x has to be equal to secant squared x. And that is straight from your formula sheet again. So as my presentation loads here, because unfortunately it's taking a while to do that, you can write that down on your notes. So secant squared x, and I just have to move back to where we were on the PowerPoint. Keep going. Okay. There we go. All right, so we end up with 1 over cos squared x, which just equals secant squared x. So now I have a single trig ratio. Great. So let's try the next one. Sine x plus cotan x times cos x. So another strategy I use whenever I see any type of reciprocal function or even tan, right? Something that I can write as a fraction, I'm going to replace that with a fraction. So if you go back to your formula sheet, you will see that cotan is equal to cos over sine. So we are going to replace that cotan with cos over sine. Okay, so now we have sine x plus cos times cos is cos squared x all over sine x. So this actually looks pretty similar to what a question we just saw. So we have a fraction and a non-fraction. So in order to join this as one fraction, we need a common denominator, which in this case is sine x. So I'm going to need to times my expression on the left by sine x over sine x so that I can use that common denominator. Sine x times sine x just gives me sine squared x plus cos squared x all over that common denominator of sine x. So once again, sine squared x plus cos squared x, it's a Pythagorean identity and it's equivalent to 1. So I have 1 over sine x. 1 over sine x is a reciprocal function, it's a quotient identity. So 1 over sine x is the same as cosecant x. So cosecant x would be my final answer. All right, let's try factoring. So I'm going to use a different color to factor. Let's try pink. Okay, so what can I factor out of this? I can factor a 3 out. So let's go ahead and factor that 3 out. So I have 3 cos squared cos 4 theta minus sine to the power 4 theta. Now you might not see it, but this is actually a difference of squares. Cos theta to the power 4 minus sine theta to the power 4 is a difference of squares. And it's equivalent to cos squared theta minus sine squared theta times cos squared theta plus sine squared theta. Okay, so we can't really do anything with the cos squared theta minus sine squared theta, so it'll just stay like that. But the cos squared theta plus sine squared theta, we've just seen in the last 2 previous questions, that equals 1. So we can replace that with 1. And then our final factored answer is just cos squared theta minus sine squared theta. Great. Okay, let's try over on the right side. So when I look at sine squared theta plus sine squared theta cotan squared theta, hopefully I should recognize I can factor out a cos squared theta or a sine squared theta there. Sine squared theta divided by sine squared theta leaves me with 1 because anything divided by itself is 1. If I take a sine squared theta of the second term, I'd be left with cotan squared theta. Okay, so now we're going to look and see if we find this anywhere. Hopefully my PowerPoint doesn't freeze on me this time. So 1 plus cotan squared theta, if you go to your formula sheet, hopefully you will see it. It's the 1, 2, 3, 4, 5, 6, 7 row down on that trig section. So it's equal to cosecant squared theta. Oh, good. So I'm going to replace it with cosecant squared theta. All right, cosecant squared theta is the same as 1 over sine squared theta. So now we can actually cancel these sine squared thetas out, and it just leaves me with 1 as my final answer. Okay, before we end today's lesson, we're actually going to look at a diploma question. This is considered a standard of excellence because we are going to find a solution, but we're also going to use an identity. So it's kind of like what you did last lesson plus what you did this lesson together. So the problem here is you can't factor anything. You can't solve for anything because you have two different trig functions in this statement. So I need one trig function. If you remember, we saw that cos squared x plus sine squared x equals 1. So if we were to rearrange this equation, we could rearrange it as cos squared x equals 1 minus sine squared x. Now I can actually substitute that 1 minus sine squared x in for that cos squared x. And once I do that, you will notice that there is only one trig func ratio now, sine. I no longer have the cos. So I can factor the 2, and then I can just solve this question just like I did yesterday. And again, just like we talked about last lesson, you could easily graph this as well. Okay, so I'm going to collect like terms. So I end up with negative 2 sine squared x plus sine x. 2 minus 1, of course, is minus 1. Okay, I'm going to take a negative out and divide it to the other side just so I end up with some positives to work with here. So all I did was take a negative out and then divide it to the other side. Right, 0 divided by negative is just 0. Okay, so now I can factor this. Let's do this on the other side here. So we're going to replace the sine x with a. So let sine x equal a. Two numbers that multiply to give me positive 2 and add to give me negative 1 are negative 2a Oh, and I just realized I made a mistake here. 2 minus 1, this should have been a positive 1. And then once I divided the negative out or switched the sign, it should have became a negative 1. There we go. That makes more sense. Okay. That looks better. Okay, so two numbers that multiply to give me negative 2 and add to give me negative 1 are, of course, negative 2a and positive 1a. Okay, I can factor each half here. So on the left-hand side, I can take out a 2a, which would leave me with a minus 1. On the right, I can't take anything out, so I'll just remove a positive 1, which leaves me with a minus 1. And my expression is 2a plus 1, a minus 1 equals 0. Now that I've factored, I can replace, and I'm just going to actually erase this up here. Whoops. Is it going to erase for me? There we go. And then continue the question up top because I wrote a little too big here. Okay, so I end up with 2 sine x plus 1 as one factor, and my other factor is sine x minus 1. So I can solve both of these factors. I end up with sine x equals negative 1/2 as well as sine x equals positive 1. Hopefully you'll realize that both of these factors are on the unit circle. So I'm just looking, where is sine x equal to negative 1/2 within my domain here. So I'm looking from 0 to positive pi and then 0 to negative pi. So where is sine x equal to negative 1/2? Let's look at our unit circle. Sine x is equal to negative 1/2 at 7 pi over 6 and 11 pi over 6. So 7 pi over 6 and 11 pi over 6. So obviously we're going to be looking at the negative angles here. Oh dear, it looks like it froze again. So my 11 pi over 6 is the same as negative pi over 6. My 7 pi over 6 is the same as negative 5 pi over 6. And again, you can easily double check this by using your graphing calculator. Unfortunately, my presentation seemed to have froze again when I went to that other screen. All right, so the next one here, sine x equals 1. So you can go back to your unit circle. I may as well since this one's frozen. Sine x equals positive 1 at pi over 2. So you will be using the positive angle there. So then my three solutions would be negative pi over 6, negative 5 pi over 6, and positive pi over 2. And it looks like my trig lesson is loading again. Unfortunately, I gotta scroll all the way back. We can see all the fun stuff we've done in trig already. And I'll just write my solutions there. Okay, so I have right here, negative pi over 6. Over here, negative 5 pi over 6. And then right here was pi over 2. So those were my three solutions. All right, trig identities is super fun. I'm sad you don't get to do this. This is like one of my favorite lessons, this fun little game. But try some of the questions in your workbook and let me know if you need any help.